All right, so I think both 3A and 3B got interrupted yesterday before we finished. So I'm going to start where 3A got to because they got the shorter end of the block, which is at the Salvi-Perez hits problem. So this was the graph we were looking at, and I think we were talking about the question about what was the maximum height of the ball. And the maximum height of the ball, I think we'd answered that actually at the vertex. So we'd found the vertex, and we'd found how many seconds before it was at the vertex, and we had gone to the zero, and that's what my screen is showing, is where the zero is at. And the zero tells us how many seconds before the ball hit the ground. And we had talked about how we can't, the y value here looks like it's not zero, but that's an extremely tiny amount, and it's just because of a deficiency of the calculator. So we have to always keep in mind that the calculator is a tool and it's not perfect. So we have to look at that number and say, oh, that's 1 times 10 to the negative 11th power. That's 10 decimal point, 10 zeros, and then a 1. So that's, really, really tiny. It's basically 1. Statistically, it's 1. Take my word for it. So the zero here is 6.92, so that means the ball hit the ground after 6.92 seconds. And we cannot determine the distance the ball traveled. We can only determine the distance up that it traveled, which I think was 192 feet, if I remember correctly, because this information is about how long the ball was in the air and how high it went. It doesn't tell us anything about a horizontal distance, so our equation is not set to do that. A reasonable domain for this function would be from 0, so we can write that from 0 and including 0 to 6.92. Because after 6.92, if you look at that graph, it looks like, the ball continues going because the graph would continue to go down. But that would be the ball being buried into the ground, and of course that does not happen. So, so that wouldn't be the case. So then we go on to this area problem. Again, I think one class we had pretty much finished it, but the other class not. So if you look at this carefully, those of you that have seen this already can pass forward. But we have a field here, and this is the original field here that's outlined here. That is 600 by 400 meters in area, and they want to double the area of this rectangular field by adding x meters to both the length and the width. So they're adding the same distance to both length and width in order to double the area. So the original area of the field, is length times width. Oh, I'm sorry, my screen jumped there. See if I can get this back. Area is length times width, and the original length and width are 600 times 400, which is 24,000. So the original area of this park or nature preserve is 24,000 square meters. Oh, excuse me, I left a zero out. It's 240,000 square meters. So they want to double that, so that means the new area is going to be 480,000 square meters, which is going to be the new length times the new width. Well, the new length is going to be all of this, which is not just 600, but it's 600 plus x. So we have this 600 plus x times the new width, which is all of this, which I bet you've guessed it, is 400. This is not going to fit. Plus x. It's not a very good way to write that, but I think you see what it says. And so we have this equation of 480,000 equals, let me write this better here, 600 plus x times 400, whoops, parentheses, 400 plus x. I hope that's more legible now. And the deal is we're going to put this in our graphing calculator to get the answer. But in order to do that, we have to set it equal to 0. And to do that, we're going to subtract 480,000 from both sides, which gives us 0 equals 600. We don't have to do anything else with this. It's just fine in parentheses. 600 plus x, length times width, plus 400 plus x, and then minus 480,000. So you're probably wondering, well, why did we have to do that? Because we're going to look at this graph where y equals 0. So we're replacing 480 with 0, because then in our calculator, we type in y equals, and I'm going to clear this equation out, and I'm going to put in parentheses 600 plus x, close those parentheses, times 400 plus x, and then minus 480,000. And if I can see where this graph crosses the x-axis, that's where y equals 0, and that's going to be my solution that I'm looking for. So I start by going to Zoom 6, which is where we always begin, and I look to see, can I see anything there? Well, there's nothing there at all, so the answer can't be, whoops, I did not do that. The answer can't be anything that tiny, so it must be something bigger. So I'm going to change the window, and I'm going to look where the x maximum is bigger, because I'm looking for where it crosses the x-axis. I don't care about the vertex at all. So I'm going to change that x maximum to 100. And I'll change my x scale to 10, because I don't need it to try to mark every single number. So now these tick marks are every 10. And gee whiz, it still doesn't see anything. So I'm going to go back to my window, and I'm going to change the x maximum to 200. See if I can see anything now. So I'm looking and I'm looking, and oh my goodness, there's this little line over here right on the edge. Looks like it must be something really close. So I'm going to go back to window. I'm going to change it to 220 and graph that. And let's see what we see. Oh, we see something. Man, that looks like a line. That's crazy. Well, this graph, if you look at the a value is 1. So I know that this graph is a graph. Oh, the screen keeps jumping. I don't like that. I know that this graph is a graph where a is 1, so it opens up. I know it opens up. It's going like this. And this vertical part down here is what we just looked at. And over here. And it looks like it's going straight up because it's so steep, because these numbers are so big. And so I'm going to have to find that 0 value. I'm going to have to find out, well, where is that line crossing the x-axis? So I'm thinking, hey, this graph, it's really going like this. It just doesn't look like it. It's kind of curving up. So when I go and ask it to calculate that 0, it's going to ask me for a left bound and a right bound. So I want a left bound where it's on this side. So that means the x value is going to be positive. It's going to be over here. But the y value is going to be under the x-axis. It's going to be negative, because I'm trying to get it to find this point. And so then when I go, it asks me for the right bound. It's going to be up here somewhere, so the x value will still be positive. But the y value will also be positive, because that'll be above the x-axis. So I've got to have that picture in my head of what's going on with this graph. So here I go. I'm going to go second and calc and 0. I'm looking for the 0. And I'm looking down here at the x values. And the x is positive and the y is negative. And I'm looking over here at my little picture I drew. X is positive, y is negative. That's great. I'm going to hit enter. Okay. Now I'm going to arrow to the right for my right bound. And I want x is positive, y is positive. Oh my gosh, look at where it is. It's way... It's not even nearly positive yet. Not nearly. Oh dear, my silly calculator went away. Okay, x is positive. I'm looking for y is positive. Y positive. Come on, y. Oh, there it is. Y is positive. I'll hit enter again. And it says guess, so I'll try to get close. Alright, I guess that's as close as I can get, so I'll hit enter, and there's my answer. X is 0 when, or x is 200 when y is 0. So that point is at 200. My cat wants in. That's what that noise is. So x equals 200 is my answer. And I know that's the amount that they're adding to the field is 200 meters. Man, this keeps jumping around. I am sorry. All right, so that's that one. Now the last thing to do, I have to just kind of talk you through because it's turning on an app that will let you graph inequalities, and it's pretty cool. And the one class got to start it already and the other class didn't. So on your calculator, unfortunately, I don't have this program on this online calculator, so we're just going to have to do the best we can. But you're going to go to this key over here that's got the purple on it where it says APPS, apps. It's in the second row, this third row, the second column. And you push that button, and that's all I have, so I don't have it. But on your calculator, you're going to arrow down and look for the app called N equals, INEQUALZ. And you're going to select that. And then it says touch any key, so just touch any key, and that's fine. And that's going to allow you now to graph an inequality, and it's going to show you the right kind of line, and it's going to shade the right area. It's pretty cool. So what I want you to do is, your screen probably already shows the Y editor, and it looks different. At the top there's an X equals, so we can graph a vertical line if we wanted to. And what I want you to do is, if there's any equations in there, clear them out so that you've got a nice clean screen. It's just Y equals. Now arrow to the left so you're on the equals sign next to a Y1. And we want to change that according to our inequality here to less than or equal to. So at the bottom of my screen, I see that less than or equal to is above the zoom button. So I hit alpha, which is the green button first, and then the zoom button, and it changes that sign to less than or equal to. And then we're going to type in negative 2x squared plus 3x plus 4. And so I'll let you do that. And then after you've done that, then you're going to hit graph, or zoom 6 would be better actually because our window's messed up. So hit zoom 6, and it's going to draw that graph for you. You're going to see a solid line. It's going to shade in the correct region, which will be inside the parabola, the upside down parabola. And that's going to be pretty cool. Then the next thing on your note guide says determining if a point is a solution to an inequality. Well, if let's say I give you a point and I ask you, so on your inequality that you just graphed, is point 2, -1 a solution? Well, if you can see that it's a solution, like if you can tell right away, oh yeah, that's definitely in the solution region in the shaded part, well then you know that's true. But if you don't, then you can trace. You can use the trace button and just, use your tracer and arrow it over and down, and you can watch the X and Y values on the screen until you're close to point 2, -1. And when you're there, you'd say, oh yeah, that's definitely inside the shaded region. So this would be a really useful app for you if you need to graph in any inequality. So I hope that helps. Complete your assignment now and have a great weekend. I'll miss you guys, and I hope this is enough information and not too much. Okay, talk to you on Monday, and have a good weekend. Be kind.